So with part 2 of this questions video, let us now draw the graph. Well, my first inequality was 5x plus 4y is less than or is equals to 40,000. Now to draw this line I need 2 points, and for 2 points I need 2 coordinates, and for that I will assume 2 values for either x or y or one value of each. Generally it is a better idea to assume what will be the y's value if x is 0 and what will be x's value if y is 0, since one term becomes 0 and the solution is easy. However, you can use any other values, you just need any 2 points to join and make a straight line. Well, if x is 0, we know that the 5x will become 0 and therefore the y value will be 10,000. And if y is 0, x will be 8,000. So two coordinates for my first inequality will be 0, 10,000 and 8,000, 0. My second inequality, which is 3x plus 6y is less than or is equals to 30,000. If I apply the same rules, if x is 0, y will be 5,000, and if y is 0, my x will be 10,000. So these are my second coordinates. The third inequality, interestingly, is a different one than one we have always encountered in our past paper questions. If you assume x is 0, y will be 0, and if you assume y is 0, x will also be 0. So for any equality which is in this sort of form, which doesn't have an extra constant number with it, you can take 0, 0 as one equality, since if x is 0, y will also be 0. And for another point, use any value of x that you like. For example, you can use x is equals to, let's say, 5,000. So if x is 5,000, what will be the value of y? Y will be 5,000 divided by 4, which is 1250. You can take x is equals to 10,000, and if x is 10,000, y will be 2,500. Point to note is that to make a straight line you need 2 points. You need 2 points and you join them and you make a straight line. So you can have any point you want. And after that I have x is less than or is equals to 6,000, and any line of this form, x is equals to c form, is a straight line parallel to y-axis. One more trick in this question which was used was that if you observe this inequality, it is x is less than or is equals to 4y. X is less than or is equals to 4y. Now students think that if the sign is less than or is equals to, we must shade the area beneath this line. I have discussed in one video how do we identify what area to shade, but for simplicity and to skip the repetitions of previous video lectures, remember one rule, and the rule is that if you remember things like that if it is a less than sign, I will shade the region below the line, and if it is a greater than sign, I will shade the region above the line. For this this specific rule to apply, you must remember that the y must always be on the left hand side. If y is on the left hand side, it is fine to use this rule. Over here y is on the right hand side. Now I will not discuss the depth of why this is so, since I have discussed these things in a previous video. So if it is written as x is less than or is equals to 4y, which means x is less than or is equals to 4y, I can write it like this: 4y is greater than or is equals to x. There is a basic maths rule, that if you shift something to the left hand side, this opening will remain towards that particular constant and number, because what we were saying over here was that x is less than 4y. Therefore definitely 4y must be greater than x. So always remember that if you are given some inequality like this, change it into 4y is greater than or equals to x, bring y to the left hand side, and yes, now you can follow the rule that if it is a greater than or equals to sign, I will shade the region above this line. If there is a less than or equals to sign, I will shade the region below the line. So now we can draw our graph. We have discussed several questions in which we have drawn our graph. If you will draw your graph, the graph will look like something. It will look something like this. I am sharing the iCaps snapshot of the solution for graph. So here is the graph. If you will draw all the lines on a proper graph paper and identify the feasible region, you will find this as your feasible region, which is satisfying all these inequalities. A feasible region is a region which satisfies all the conditions or all the constraints simultaneously or at the same time. Now, since our objective was the maximization of profit, we will apply the corner point theorem, and we have three corners. Corner number one is this. Let's name it as A. The second one is over here. Let's name it as B. And the third one is over here. Let's name it as C. And what do I do is that I calculate the profit amounts at each of these and opt for a position which has the highest contribution. So till here I have discussed the how do we draw graph. I assume that you all will proceed with the video once you have drawn the graph over here. Okay, now if I identify all the corner points, I know that one of these points is point number A, and A is at y-axis, and we did calculate its coordinate. A with y-axis was this, maybe. Let us just confirm. Yes, exactly. If you draw and identify A will be 0, 5000. So the coordinates of A are 0, 5000. Since this green line is intersecting the y-axis, so this is 0, 5000. For point B, I know that point B is at the intersection of that green line and the red line, and the green line's equation is 3x plus 6y is equals to 30,000, and the red line's equation is x is equals to 6000. To find any point, we solve the equations simultaneously, and if I will solve this simultaneously, I will get x as 6000, comma y as, if I substitute x value in the first equation, 3 into 6000 is 18,000. 30,000 minus 18,000 divided by 6 is 2,000. So point B is 6,000, 2,000. Now do I actually need to calculate the coordinates of C? No, I don't. Why? Because I am finding the contribution maximization point, and I can see that B and C lie on this red line, which represents that the x coordinate of C will also be 6000, and since C is below B, its y value will be less than 2000, meaning I will be producing less units of y. Therefore the calculations of C are not relevant. You can skip this, just like you skip this corner point of a feasible region. It was a corner point, it was on a feasible region, but you knew that over here the x and y will be 0 each, and therefore there is no need to calculate contribution on that point. So I have 2 points. A is 0, 5000 and B is 6000, 2000. And now if I calculate the profits at both these points, my contribution function as I derived in the previous video was 900x plus 740y. If I am producing at point A, I will produce 0 of x plus 740 into 5000, and 740 into 5000 is 3,700,000 or 3.7 million. Sorry, 370,000. Actually it is 70,000. Sorry, again it's a million, 3.7 million. At point B, my contribution will be 900 multiplied by 6,000 plus 740 multiplied by 2,000, and 900 into 6,000 plus 740 into 2,000 is 6.88 million. So I will be producing at this specific point. Okay, the question has one more part, and in that part it says compute the shadow prices of scarce resources assuming that maximum demand remains constant. So you have to calculate the shadow price. And what is shadow price? If I had one more unit of scarce resource, how much can I increase my contribution by? Well, for this I need to identify point B. Point B is over here, which is the intersection of the green and the red line. And the green line, what did this green line's equation represent? The green line's equation represented labor hours. And since I have limited labor hours, I have utilized entire labor hours. Since I am at the boundary of green line, I have used all my labor hours. I cannot produce more than this. If you want to prove, let's prove it. The equation for the labor hours is 3x plus 6y is equals to 30,000. And since I am maximizing my profit, I am producing 6,000 units of x and 2,000 units of y. And each unit of x requires 3 labor hours, therefore 6,000 units will require 18,000 labor hours. And each unit of y requires 6 labor hours, and 2,000 units of y will need 12,000 labor hours. In totality, they are 30,000. So what has happened is that I am producing at this boundary because I have exhausted the labor hours limit. Now, how do I calculate the shadow price? I say, what if, let me write the original equation. Original labor hour equation is 3x plus 6y is less than 30,000. I say, what if I had one additional labor hour? If I had one more additional labor hour, my equation would have been 3x plus 6y is less than or is equals to 30,000 and 1. And if I had one more labor hour, maybe I will be able to produce an additional unit of either x or y or partial unit of each. So if I had 3x plus 6y is less than or is equals to 30,001, if I had one more labor hour, now my green line had a revised equation of 30,001 and the red line had equation of 6,000, x is less than 6,000, and my corner points would have been 6,000, and for y 3 into 6,000, 30,000 and 1 minus 18,000 divided by 6 makes it 2000.17. If I had one more labor hour, I could have produced 0.17 more units of y, additional or more units of y, if I had one more labor hour. So I can say that if I had one more labor hour, I could have produced 0.17 more of y, and I could have increased my contribution by 0.17 into 740, which was the contribution per unit of y, and I could have increased my contribution by 740 into 0.17, which is 126. One way of finding the shadow price is this, and what is shadow price was discussed in the class as well in detail, what this 126 had, what implications it had. Second method is to find the shadow price is to calculate the new contribution. New contribution at 6,000 units of x and 2,000 and 0.17 units of y. The new contribution would be 900 into 6,000 plus 2000.17 into 740, which makes it 6880126. If I had one more labor hour, I could have generated a contribution of 6880126. Previously, I had a contribution of 6880000, and therefore one more additional hour could have added to my contribution 126 rupees. This is your shadow price.